Alright, I'm doing my presentation on EEVs. So, electronic expansion valves are an evolution on the thermal expansion valve. They're much more sophisticated and allow the refrigeration system to operate more accurately and efficiently. You'll usually see electronic expansion valves listed in the acronym of either EEV or EXV. They both mean the same, it doesn't really matter. Just depends on the manufacturer. Benefits of the EEV are you reduce energy consumption with better refrigeration performance. They also have precise control, more so than a standard TXV does. It has very fast response, a load change, and a wider load variation than a TXV can. It can maintain maximum capacity control even at part loads and injects exactly the right amount of refrigerant every time. Has an energy savings of up to about 30%. How does it work? The expansion valve causes a pressure difference between the condenser and evaporator. It holds back the high pressure liquid refrigerant and decides how much to let through into the evap. As the high pressure liquid refrigerant bursts through the small gap between the valve seat and needle, it drops in pressure. This will result in some of the refrigerant vaporizing, and the rest will continue through as liquid. The pressure is measured and converted by the controller using the stored data for the refrigerant being used in the system. To find the saturation temperature, this is then compared to the actual temperature measurement. The difference between the two is the operating superheat. The controller then decides whether the expansion valve should open to let more refrigerant into the evaporator or close to reduce the amount entering. When the signal is sent to open the valve, the assembly will rotate in the opposite direction and the threaded section pulls the assembly up. This opens the valve and moves the needle away from the seat, allowing more refrigerant to flow. The controller is constantly taking pressure and temperature measurements and sending signals to adjust the valve position to suit the load. These valves can be pricey depending on the system it's going on. Prices of the valve are typically around $120. The internal workings of an EEV consists of the main body of the step motor is a permanent magnet. This permanent magnet is affected by an electronic magnetic field of the coils. The change in the polarity of the electromagnetic field will cause the permanent magnet to rotate. I can't talk today. Attached to the permanent magnet is a shaft. Some designs will use a gear assembly between the motor and the shaft instead, but as we're only looking at it, simple designs will stick to the stick with a directly coupled shaft. Okay. On the shaft is a thread. This thread sits within the holder, which is attached to the valve body. At the end of the shaft is a valve needle. Then we have the valve seat, which the needle moves into and out of to close and open the valve and control the flow of refrigerant. They will have some temperature and pressure sensors and take measurements of the refrigerant in order to calculate the superheat. And this will be connected to a controller. The controller is connected to the step motor and will allow how much to open or close the valve. In conclusion, the EEV is a very sophisticated valve, but is way more efficient, performs better than your standard TXV. And that's all I got. Thanks.